friends. We're back with a little math outreach lesson. This is the Monday lesson for volume day 1. The materials you're going to need in order to follow along with this video and to complete the lesson fully is your outreach packet, some sort of writing utensil, and a calculator. No need for color pencils or highlighters like we had last week, just these 3 things on the slide. All right. So to get started, when we're talking about volume, the definition is the measure of the amount of space an object occupies or takes up, which is kind of like very fancy and wordy. Essentially, when we're thinking about volume, we're talking about the inside of the 3D prisms we've been looking at. Last week with surface area, we talked about the outside of the figures. This week with volume, we're talking about the inside of these figures. So we're going to start with a think about it. It's similar to things we would do in class. And so the purpose of this slide is I'm going to kind of walk you through the thinking in each question, and then we're going to answer question 5 independently using what we did on this page. So looking at part 1, how many cubes will fit in the bottom, the base of this box? So hint, the base is represented by the gray area. So I'm looking at the base of this rectangular prism. It's represented by this gray shaded part where it has a length of 6 and a width of 3. And so remember area, when we're talking about area, what we actually are finding are the amount of cubes that would fit in the space. So I'm going to find the area of the space in order to answer this question. So I'm going to use A is equal to length times width. A is equal to 6 times 3, substituting. And I get A is equal to 18 inches squared. So this means, because area means to fill the space with cubes, in this case they're 1 centimeter cubes. I don't know why I put inches there, it should be centimeters squared. But they're 1 centimeter cubes. That means I can fit 18 cubes in the bottom of this box. I'm going to go ahead and try to draw these in. It's going to look very bad and not uniform, but it's totally fine. We're just going to pretend Miss Lewis can draw. Ooh, that one was a little too big. So I can fit 6 cubes on this first row across, and I can fit 6 cubes again. I can fit 6 cubes across this base 3 times because I have a width of 3. This looks so bad. Just narrating. Classic Miss Lewis handwriting right there, am I right? So I have 18 total cubes. If you count these up, there's 18 of them in the base. The second question is asking how many times can I put these 18 cubes stacked on top of each other in the box. So it'd be like I put this base, and then I put 18 more cubes, and I put 18 more cubes, and I put 18 more cubes, so on until the box is completely full. It's important here to think about how tall the box is. So we've been looking at this base. It's important to know this is a 3D prism, so it's not flat. It says from the base to the other congruent base, there's a 4 centimeter difference. So that means my current prism is 4 centimeters tall. That means I can fit 4 rows of these cubes in this prism because each of the cubes are 1 centimeter, right? So how many times does 1 go into 4? 4 times. So I can fit 4 cubes from the bottom to the top. So I can stack the 18 cubes 4 times. Just struggling with this pen right now. It's okay, the next one I don't need to use the pen. So how many cubes are we going to fit in this box? This is going to be the volume. So let's kind of recap what we talked about in questions 1 and 2. So there's 18 cubes total in the base. We can stack those 18 cubes 4 times. So I'm basically repeating the 18 cubes 4 times, right? So I do 18 cubes, and then 18 cubes again, then 18 cubes again, and then 18 cubes one more time to fill this in total box. That means I'm probably going to have to multiply 4 times 18 because that's repeated addition. So I do 4 times 18, and that's going to be equal to 72 centimeters cubed. And key point here, when we're talking about volume, remember we're cubing our units, not squaring like area. We're cubing the units for volume. All right, so what did we actually end up doing here? How can I use this to find the volume of other shapes? We're going to learn that in question 4. So the variable capital B, important to know it's capital B, stands for the area of the base of this box. Which, guess what? We found that in part 1, right? I found capital B by finding the area of this base. And the variable h represents the height of the box. And we did that in part 2, right? We said this is how tall the box is. That's going to be the height. So I already have the area of the base times the height that I did here. I have my height times the area of the base to get our total volume. So my volume formula is going to be capital B, the area of my base, times the height of the figure. So important here, I keep saying capital B because when we have a lowercase b, that just stands for the base. That would stand just for the gray area by itself, just that rectangle on the bottom. Capital B stands for the area of the base, not just the base, but the area. So it's an important difference between the two. All right, if you're still a little bit confused about what we did here, go ahead, send me a text or get on a Zoom office hours so you can have a little bit of clarity if you're still a little stuck. But we're going to move on to question 5, which you're going to complete independently, but I'm going to give you a little hint. All right, moving on to question 5. It says, suppose we bring the box to its side. So we kind of turned it over. The base is now 4 centimeters by 3 centimeters. So this is now considered our base down here. And the height is now 6 centimeters. Does this change the volume of the box? So the big hint here is, does order of multiplication matter? That should be your big piece of evidence in your answer. You can also think about what we just talked about on the last page. We said we want to multiply the area of the base times the height. If you want to match the answers, see if they match up or not, using the order of multiplication as your evidence, we have the area of the base times the height. Does the order of multiplication matter? Does the volume of the box really change by flipping it on its side? Go ahead, pause this video so you can answer this independently. Then once you're done, just unpause and we'll go over the key points on the bottom. So our big key points for volume is volume measures how much space an object takes up, or in other words, how much an object can hold. We find volume by multiplying the area of the base, that capital B of the 3D figure, and the height h of the figure. And we measure this in units cubed, not squared, units cubed for volume. All right, let's move on to our first real example. So go ahead, using the last page, fill in the notes for your own reference. So volume measures the blank an object takes up, and volume is equal to what times what. And then again, we measure this in units cubed with that little 3 exponent. All right, so this first example, we want to find the volume of the tissue box. This tissue box is a rectangular prism. That means, like we talked about last week, the base of the prism is a rectangle. I'm going to consider this part of the base for right now. So let's look at this first part. When I'm finding volume, the first thing I need to do is find the area of the base. You'll notice here, I have my area formula for a rectangle, but the thing I changed here is I labeled it as capital B, not A. I labeled this as capital B to remind myself I was solving for the area of the base, and then I can substitute my answer here into the formula. That way I don't forget steps, or if I'm just being a little bit lazy, I know what I need to put where. So the first thing I'm going to do is I have capital B equals length times width. I substitute in 9.2 times 25, the length and the width of this base, and then my base then is equal to 230 units squared. This is just area, so my units are squared. Remember, when we don't have units, we need to write U or units instead. So that means for the volume of my prism, I use my formula V for volume equals the area of the base times the height. I'm going to substitute in this 230 units cubed times 10 units. So here at this E-block challenge, I'm going to pause really quickly because this step might help you answer this here. I have 2 U's here because I multiplied 2 units together, and then I have a third unit here. So try to maybe explain or show why it's units cubed and not squared for a volume. Send me a picture for an E-block. And then finally, when I multiply these together, that means my volume is 2,300 units cubed. Before we move on, I want to show us something a little bit different. So here, I put B is equal to length times width, but this one I put 10 times 9.2, and I got 92 units squared. And then I multiplied it by 25 as the height this time to get the same volume. Why do you think I got the same volume this time. There's kind of two different answers you can think of. So if you're thinking about the last page, what was important there was that the multiplication order doesn't matter. And for volume, we're really just multiplying a lot of different things together, especially for my rectangular prisms. But the big thing here is that when I'm having a rectangular prism, any side of that rectangle can be the base, right? Because they're all rectangles. So if you didn't pick this as your base and you picked maybe the side as your base or the top as your base, that's fine. You would get the same answer because any face of a rectangular prism can be considered the base. All right, going on to practice 1, example 2. Find the volume of the die below. Use your excellent work steps that are shown above. So we know this dice is the shape of a cube because all the sides seem to be equal. That means the base of this prism is going to be a square. So I'm finding the area of the base of the square. So my capital B, the area of the base, is equal to side times side. I substitute in 2 times 2. Everybody should be able to get this on their own. I don't need to write this number in. Make sure you're including units squared. Now I'm going to go ahead and do the volume of the prism. V is equal to capital B, the base, the area of the base of my prism, times the height. I substitute in 4, which should be the answer to part A, times the height of 2 to get 8 units cubed. Awesome job, my friends. I find volume so much easier than surface area. So let's move on to the next page. All right, moving on to the next page. This first question is asking us to find the volume of the toy chest shown here. And so it's important to realize this toy chest is in the shape of a rectangular prism. So that means the base of the prism is going to be a what? Yes, a rectangle. Pretty simple. So that means for this first part, the area of the base of my figure, we need to find the area of the rectangle. So I'm going to put my capital B, the area of the base equals length times width. And then I'm substituting in the dimensions of the base I chose to use for this rectangular prism, 4.5 and 2. Then go ahead and make sure that answer is calculated with feet squared. If you need to pause this video to make sure your answer is correct, you can go ahead and do that, and then we'll move on to the second part, finding the total volume of the prism. All right, so now I have this unknown area. You should have it on your paper. That's going to be useful in my formula for volume, which is equal to the area of the base, the capital B, times the height of the prism. So make sure you're filling in the capital B you got from the first part, and then multiply it times the height of 2. And you should go ahead and get your final answer in feet cubed this time, because now we're finding volume. Again, pause in the video if you need to make sure that this answer is 100% complete. And then we'll move on to question 2. Question 2, the steps are going to look basically the same. I have a rectangular prism, so we know that base is going to be a rectangle. I'm going to choose the bottom base again, and I'm going to find the area of the base. B is equal to length times width. B is equal to 10 times 18, and then go ahead and fill in whatever that is going to be in inches squared. Taking some time to make sure it's correct, then moving on to the volume. So volume is equal to base, area of the base times my height, the capital B times H. V is equal to whatever you found for part A times the height of 6, and then you're going to get your answer in inches cubed. Once you have this answer filled in, and all the answers on this page, we're going to go over that last question that looks a little bit different. All right, moving on to the next part. Question 3 is different. So the question's asking us, what is the height of a rectangular prism with a base of 33 inches squared and a volume of 132 inches cubed? Go ahead, just take a couple seconds. What makes this problem different? You're right, so we're given the volume this time, and it's asking us to find the height of our prism. It also gives us a base of 33 inches squared. Because this is in inches squared, we know this is already capital B. We already know this is the area of the base because 33 inches squared indicates we found the area of that base. So I'm going to go ahead and still use my volume formula, but we're going to put different parts in for the pieces. So I have capital V volume is equal to the area of the base, capital B, times H. But this time, instead of filling in the area of the base and the height, I'm going to substitute in for volume and the area of the base. So my formula should look like 132 is equal to 33 times h. Now, how do we find h? We have to think all the way back to the beginning of the year when we talked about equations. Our goal of an equation is to isolate the variable. How am I going to isolate this h on this side? What would I need to do? Think about it. You're right, we're going to have to divide by 33 on both sides. So we're going to go ahead and divide by 33 to get that h all by itself. And once you do 132 divided by 33, you should get your answer. It will be one of these whole numbers in your multiple choice. Pause in this video until you have your final answer. Then we're going to go on to a little announcements page. All right, next page. So you still have one more section to do, just a couple more practice problems. Go ahead and try it on your own using your notes and this video. If you need any more help, you're welcome to text me, and you also should be joining office hours with Miss Douglas or Miss McNeely's on Zoom. All of these options would help you earn some blocks for the virtual block raffle Mr. Conley announced earlier this week. So definitely reach out to your teacher so you can earn some blocks so you can be in the raffle for these cool prizes. And like last time, there's going to be a Google form in the description so I can help you better and just like check in, wonder how you're doing. And then 2 other block opportunities for you is filling out the form gets you a block. And if you watch this whole video, send me a picture of you watching it for blocks as well. Because I spent a lot of time on this, I want you to utilize it and enjoy it, please. And you get incentivized for utilizing and enjoying it. So thank you for listening. We're going to have a whole week on volume and surface area. So stay tuned for more videos from me on these topics. Thank you for learning with me today. Miss you.